All right, number 24. A submarine dives at 110 meters at an angle of 10 degrees below the horizon. What are the two components? So this word components tends to bother people, but let's first make a drawing. The submarine dives 10 degrees below the horizon. So it's a very shallow angle. And the horizon, we should make blue like water because it's a submarine. The horizon's there. So there's your horizontal component. And then this would be your vertical component. And they're just saying find the two parts. Submarines probably aren't going to dive at 10 degrees the other way because like everyone on the ship would start tumbling in certain directions. It would be very unsafe for the crew. When they say components, horizontal and vertical components, this is what we're talking about. The horizontal component, the horizontal part. The vertical component, the vertical part. That's what we're talking about when we say horizontal and vertical. Just use SOHCAHTOA there. I'm not going to do these right away. I'll make a whole separate tutorial on those. So we're on 29 here. Does a ball dropped out the window of a moving car take longer to reach the ground than one dropped from the same height from a car at rest? No, the two would take the exact same amount of time. It's just a matter of the fact that one's moving sideways while they're going. If they fall from the same height, they will take the same time, which leads us to number 30. A rock dropped at the same instant that a ball at the same elevation is thrown horizontally. Which one will have the greater speed when it reaches the ground? Well, that's interpretive. They're both going to take the same amount of time to fall, so their vertical speeds will be identical. However, the ball that is thrown to the side, can I have one of these paths going on? Will have both a horizontal velocity and a vertical velocity. So I would say that one has a greater speed when you combine the two speeds. However, the vertical velocity of the one that is dropped will be identical to the vertical velocity of the one that's moving sideways. And then let's do number 31 together here. 31. The fastest pitch recorded at the time of this book being published was thrown by Nolan Ryan in 1974. I googled it. This is no longer accurate, but we'll still do the problem. The ball will fall 0.809 meters by the time it reaches home plate. And it is going a horizontal distance of 18.3 meters. How fast was the pitch? So what we know is we know the distance of fall, and we know how far sideways the thing goes. So that means we know delta y and delta x. What we need to do is we need to use delta y to find the time, and we need to use delta x with that time to find the velocity of this pitch. Now I will tell you the new world record, it was set in baseball in 2010. If I look here on my little generator, it was thrown by Aroldis Chapman at Petco Park, and I have no idea where Petco Park is and what team he plays for, but says the fastest pitch, at least from this generator here, is 105.1 miles per hour. I then did a quick Google change. 105.1 miles per hour is 46.9 meters per second, almost 47 meters per second. So take that, and that is actually the true world record, in case you care, and you probably don't care. And that will be all I record in this one.